Okay, so for our next lesson, lesson 4, we're going to be rewriting formulas and equations. So I started off this lesson by giving you guys some really common formulas, and the way I define a formula is it's an equation, but it's an equation that has more than one variable in it. So a lot of times you're going to use formulas in science, very common, and you've probably seen a lot of these before. I know you've seen the geometry ones if you've taken my geometry class, but these are just reminders of the formula, the quantity it's looking for, and the meaning of the variables in that formula. So what we're going to talk about is how to rearrange these formulas so that if I'm solving a problem with distance and I need to find either the rate or the time, how do I do that using the formula in a different way? So the first formula we look at in example 1 here is the formula for circumference. And it's a pretty straightforward formula. It's C equals 2 pi r. Now I know we read it as 2 pi r, but you got to think of it as 2 times pi times r. So what this is asking us, or what we're trying to do here, is find the radius of a circle with a certain circumference. So if I'm looking for the radius of a certain circle, what I want to do with this equation or this formula is I want to take the formula and rearrange it so that I have the radius on one side. So I have it solved for the radius. So I'm going to rewrite this out as circumference equals 2 pi r. For me to solve this, I've got to undo some operations, meaning I have to move 2 to the other side, I have to move pi to the other side. And if we notice, all three of those quantities are being multiplied. So I would just undo them by dividing both sides by 2 pi. Now I could have divided by 2 and then divided by pi, but since they're all being multiplied, it's a little bit more efficient to just divide by 2 pi right away. So this formula becomes radius equals, circumference over 2 pi, circumference divided by 2 pi. So this makes it much easier to solve when I know the circumference and I'm trying to find the radius. So to find the radius, I take my formula and I substitute in circumference. So that's 26 divided by 2 pi. Now, if I'm doing this in my calculator, you got to be careful because when you type it in, certain things can happen. So make sure that if you're dividing 26 by 2 pi, when you hit that divide symbol, make sure you put the 2 pi in parentheses, or else your calculator is going to do some goofy things on you. So this rounded, we're going to round it to the nearest hundredth. So I would round this to 4.14 meters as my radius after I punch that into my calculator. And a lot of these formulas, especially, you're going to be getting decimals for the most part. So I would expect you to get decimals, and if you're going to get a decimal, just round it to the nearest hundredth, 2 decimal places each time. So take a minute, pause the video, do the guided practice. Once you've worked through it, once you're ready, restart the video, and then I will go through explaining how it's done, and then you can kind of check with me. So, guided practice number 1 here. It says solve the temperature formula, Fahrenheit for Celsius, and then convert the temperature, 85 degrees Fahrenheit into degrees Celsius. Okay, so I made a little bit of a typo there, then C. Forget that little C there, but converting the temperature Fahrenheit to Celsius. So, for me to solve this formula for Celsius, I got to do a couple things. So first, I'm going to rewrite it. I'm going to do that every single time. And if you're not really great with fractions, if you really want, 9/5 is really just 1.8. So you could convert that to a decimal right off the bat if you want to, that's fine, right? And then solving this is really just a two-step equation. First thing I'm going to do, I'm going to think, I got to get rid of 1.8, I've got to get rid of 32. The first thing I'm going to get rid of is 32. I'm going to take care of that addition first. So I subtract 32 from both sides. So this becomes F minus 32 equals 1.8 C, 1.8 times C. right? And then next, I am going to divide both sides by that 1.8, okay? So when I divide both sides by 1.8, that means I divide everything on this side, by 1.8, right? So this becomes C equals, and that F over 1.8 is a little weird looking. Think of it as 1F over 1.8. So I'll just take 1 divided by 1.8. This is going to give me, in my calculator, it's going to give me 0.5 repeating, all right? So if you get 0.5 repeating, I'd be okay with you just saying you round that to 0.56 times F. So that's just a result of me taking, and I'll do a different color here to show, this is 1F. So I took 1 divided by 1.8 to get that 0.56, 0.5 repeating, but rounded, okay? And then I do 32 divided by 1.8, and that's 17, and notice that's 17.7 repeating. So if you want, 17.78 is fine for what we're finding right now, because a lot of times temperature, that's going to be easier to think of in decimals, all right? And I know if you're thinking of the temperature on a regular day, you're not going to think 0.78, 0.79 makes a big difference, but for certain things that does make a big difference. Certain calculations, it does make a difference. So now that we've done all that work, we're converting 85 degrees Fahrenheit into Celsius. So we know in this case, F is 85. Geez, gotta work on my handwriting. F is 85, a little bit better. So I'm going to plug that into this formula, right? So I know I can write it out as C equals 0.56 times 85 minus 17.78, right? And by now, we should have a pretty good grasp on order of operations and how to figure all that out. So I go through all that process. I should be down to my degrees Celsius, 29 point, now rounded to 56 degrees Celsius. Okay, so it's a good conversion to know how to do, and it's good to understand, because if you ever visit, Europe or basically any other country that uses Celsius, which we're one of the few that uses Fahrenheit, it's nice to know those conversions so that when somebody says tomorrow it's going to be 29.56 degrees, for us, we think 85 degrees. So you're not wearing a jacket in 29-degree weather. Because 29-degree weather in Celsius is actually pretty warm, right? So next, another example. Now this example is a little bit similar to our first example, solving the formula for area for length, right? It's got that weird looking L. So for me solving that, A equals LW. And I know that L kind of looks like a 1, so just be careful with that. If I'm solving for L, I'm just going to get rid of W by dividing by W on both sides. So this becomes L equals area over width. Okay? And then I'm asking you to find the length of a rectangle with a width of 11 and an area of 187. So the length would just be 187 divided by 11, me plugging in for area and width. So in the very end, thinking of my units, my length is going to be 17 feet. So that one is pretty straightforward, I think. Just a simple steps for those, okay? Simple steps. So again, guided practice. Examples that I'd like you guys to work through, pause the video, and then once you're ready to move on, check in with me, okay? So these, don't try to just follow along with what I do. Try and work them out on your own and then correct them as you go, okay? Because these do deepen your understanding of the concepts. So 2, guided practice number 2 here, perimeter. Solving this for W, it's a little tricky. So one thing I want you to notice is that we are going to actually factor something out of each of these terms for us to solve. for width. 2L, 2W, they have a 2 in common, which means I can factor out a 2. So if I factor out a 2, it means I'm just kind of working distribution backwards, right? Because if I distributed the 2 back through, it would be 2L plus 2W. So for me to solve for W, I'm going to do two things. I'm going to divide both sides by 2. So P over 2 equals L plus W. W. And then for me to solve for W, subtract length. So this is kind of weird looking. P divided by 2 minus length equals width. Right? And then me plugging in, knowing a length of 9, a perimeter of 32. Perimeter 32 divided by 2 minus 9 equals my width. That's going to be 16 minus 9. 16 minus 9, 7. So my width is 7 meters. Okay, so it's a little more work than the ones we've done before, but it's important stuff because dealing with formulas, you're applying math to concepts that are, yeah, we say real world, but they do apply to science. They do apply to a lot of other things. So being able to work with multiple variables at once is an important skill, right? It's one I want us to really develop in this section, in this lesson. So next, solving the distance formula for t. And if you've taken physics, you're going to be really familiar with the distance formula. So solving this for t is a pretty simple process, right? If I'm solving for t, undoing division or undoing multiplication, divide both sides by r. So time is distance over rate, okay? So you take your distance divided by the speed you're traveling, that gives you the time it takes to reach that destination. So the time it takes to travel a distance of 135 miles if you're traveling 30 miles an hour. Pretty common example if you've ever used, Apple Maps or anything like that. That's how that's done. Pretty simple calculation. 135 divided by 30, that's going to be 4.5 hours. Okay, 4.5 hours. So that distance one, that one's going to be really common if you ever take a physics class. Okay, any kind of physical science, they usually cover that pretty extensively. So it's a little bit longer video, but it covers a pretty broad range of things. So make sure that you're following that next step carefully and you're working through it slowly because this is a big skill. Okay, so you can move on to the next step.